Hello everyone, welcome back to Coding with West Pi. My name is West Pi and today we are going to be doing a tuple tutorial. Now, one of the biggest things you have to understand about tuples before we even go anywhere is that they are immutable data types, and by that I mean that they cannot be changed. There is no way of actually changing a value inside of a tuple, just as there's no way of changing a value inside of a dictionary. The only way there is to do it is to create a new dictionary or a new tuple, whereas an array you can actually add to the end of it. So what we're going to do also is we're going to be using some modules here for the first time, and we're going to be using the sys and the timeit module. Sys is for system, and timeit as well as it sounds for timing things. These will be very important for understanding why we're going to use tuples versus lists, because they are very similar in the way that they look, however, uh, and even their functionality, but it is significantly different. So first, we're going to import sys, and we're also going to import timeit. Now, you could do this one of two ways. You could do it like that, or you could do another import like this. But for the sake of speeding this up, okay, because we're not really at modules yet, but that's okay. So we already have these, and now just to make sure that our modules are all good, right? There's no issues, excellent. So the next step here is we're going to actually find out what we can do with the sys module. So we're going to print the dir, and that's another function inside a built-in function of Python, and we're going to use sys, okay, and we're going to run this, okay, and now we can actually find the methods, okay, and this is important because if we want to actually know what we're doing and how to find what we want to find, then we got to know where to get it. So we're going to be using this method of the sys module, which is GetSize of. So, and if you're wondering what that does, we're going to print the help, which is another function, and we're going to call the GetSize of method. Okay, so we're calling the GetSize method of the sys module. We're going to find out what that does specifically. Okay, and it returns the size of an object in bytes. Okay, and that's really important. Okay, that's definitely super important because that's the biggest takeaway here, along with time, size and time. That's what matters when we're talking about large data sets. Okay, so we're just going to create some data here. We're going to create a list 0, 1, 2, 3, 4, 5. All right, and x2 will equal a dictionary. That'll be string, and we'll have 2, which will be data. Okay, so we got some entries into our dictionary, and then we're also going to have x3, which will be also a string. Okay, and we're doing this because I'm going to show you how we can transform this into another type of immutable data. This is an immutable data structure right here. Dictionary, this is mutable. It could be changed. This cannot be changed. Okay. So, and now what we're going to do is we're going to construct some tuples, construct them from the tuple constructor or function. Okay. So x4 is going to equal tuple x1. Okay. x5 is going to equal tuple x2, and x6 is going to equal tuple x3, okay? And then we're going to print x3, x4, and x5. Sorry, x4, x5, x6. Okay, and we're going to see how that looks. Alright, and you can see that these have now constructed a tuple. The data has been transformed into immutable data structure or a sequence of data with these parentheses instead of having just the brackets, okay, or the curly braces, right? And you may think, well, this isn't really that special, right? So, and we're going to get to this more, okay? So now we're going to go over the methods here, okay? Print x6 dot, what do we have? We have count, right? Okay, right there at the top, count. We're going to count a value of s, okay, because we know s exists in our tuple, okay. And it's going to say 1, all right, excellent. And now we're going to print x4 dot index of 4, right? We'll see what that does. See if that does anything. Okay, and that's 4, so it's going to return the exact index in the tuple. Okay, it's saying 3, actually, my bad, 3. So 3 is the location of this value. Of course, as we've talked about before, the index 0, 1, 2, 3. So we end up on 4. Okay, and so now we know where the data is. We know how many counts are of this data. And again, but the problem is you're probably looking at like, well, lists have lots of methods. Tuples have like none. Can't really extend it with a new tuple or anything. Well, ultimately, this is where the GetSize of and also the timeIt module come in. So the first thing is lists are not efficient. They take more space. Okay, we don't really want that. Okay, so what we're going to do is we're going to create some new variables here, and one of them is going to be list size. Okay, and that's going to equal sys dot get size of, okay, and we're going to pass x1. Okay, so remember we have x1, which is a list. Okay, and now we're going to use tuple size. Alright, and that's going to equal sys dot get size of, and we're going to use x4. Okay, so that's the exact same data, just in 2 different structures, and then we're going to print list. We're going to print list size, okay, and then we're also going to print list, or we're going to print tuple size, okay, and we're going to see what that gives us. Okay, so you can see that this is a pretty good change in memory. Now, this is a very simple, and actually it's all the same kind of data, so it's going to be, not as much. However, if we were to add some other types of values in there, like let's add a Boolean value, and then let's also add a float, and then let's also add a string real quick. Okay, and now let's run this. Let's run this. What's that? Oh, put a comment here. Okay, and you can see how as this grows, as this gets bigger, this is going to take more and more bytes of data. Now, if we're working with, 100 million entries in a table or something, this is going to be very big, and this is going to be very, very, very heavy on our machines. So that's why it's important to use tuples when it's possible to conserve memory so you can do those computations so that you can handle that big data so your computer doesn't crash. Okay, but for now we're going to go back to just this. Okay, so the significant change, okay, that's one of the other things. Now we also have the time it module. Okay, so and what we're going to do here is we're going to do list time. Okay, that's going to equal time it, and we're going to call the time it method, and we're going to use this parameter stmt. Okay, stmt, which will allow us to execute some code. And so we're going to generate a bunch of these lists, okay, with the same exact data. And we're also going to use this number one, okay, and we're going to use this argument, which is going to equal 1 million. Okay, so we're going to do 1,000,000 iterations of this. Make sure I have the right number. 1, 2, 3, 1, 2, 3. All right, and then all we're going to do is tuple time. All right, and that's going to equal time it. Wow, time it dot time it. Okay, and then again stmt, and this time instead of using a list, we're going to use a tuple. 1, 2, 3, 4, 5. All right, make sure we're closing that out correctly. You're going to also use that number of time, number of iterations parameter again, 1 million. Okay, make sure we have our 6 zeros, 1, 2, 3, 1, 2, 3. Beautiful. Make sure everything's spelled right, and then we're going to print list time, and we're going to print tuple time. Okay, and we're going to see how that looks. What do you got going on here? Alright, just equal sign. Okay, and so this is where you start to see it, right? Is where we're doing these iterations and we're knocking off a whole 2/10 of a second, right? We're shaving off hundredths of a second, which in computer time is a lot, right? Like in human time, it doesn't seem like a lot, but in computer time, that is a lot. And so when it comes to generating or creating 1,000,000 of these tuples with just this data set, and 1,000,000 of these with just this data set, it's, 2/10 of a second to do that, or 3/100ths of a second to do that. Okay, so that is a pretty big change there. All right. So again, when you're using large data sets, 100 million entries, this is where these numbers come in, right? And that's where it may seem as though a tuple with only 2 methods and doesn't have lists, abilities wouldn't be as great. However, it's more efficient, and efficiency is ultimately king when it comes to coding and programming. So just keep that in mind when you're dealing with large data sets. And so after that, we're going to go into another concept here, which can only really be displayed by doing this. Okay, so data 1 equals an empty tuple. Data 2 equals a tuple with a string, and then data 3 equals another tuple with 2 strings. Okay, and if we print data 1, data 2, data 3, you would assume that all of them would come out as tuples. However, as you can see, there's something here that doesn't make sense. and that is this second data point, okay? And why is that? Why does this come out as a string and instead this comes out as tuples? Well, what we can do here is we can actually understand this as I said, there's a trailing comma, which means that to tuples, it requires that you put this extra comma right here to denote that this is a tuple, okay? And if we run that, now it is a tuple, okay? And you could check the type, right? You could print, we could use the type function, and we could do data1, all right? And we're actually going to change this back. We're going to remove our trailing comma. We're going to print type data2, okay? And now you're going to see this is of the class tuple and this is of the class string, okay? So if you want to make sure that you have just a single entry in your tuple, that you make sure you use that trailing comma, or else you will end up with a string and not a tuple. Or if you do, then you get your tuples. And so finally, we're coming up on tuple indexing, which, I mean, if you look at this, we're going to do age equals, let's create a variable, okay, with a tuple, and it's going to have age 26, location, it'll be Netherlands, and then we'll have the sex, which is going to be male, okay? That's simple. And if we were to index it just like a typical list, then we could print person, well, let's actually assign this to a variable, okay? So age equals person, and we'll index at 0, and then we have location equals person at indice 1, and then we have sex, which equals person indice 2, okay? And then we can just print age, sex, location, okay? And that works. All right, so we can index our tuple just like we would index our lists, okay? And then if we want to instead, we can do tuple assignment, which is another option. So we're going to try this a different way. Now, if we do person and we're again doing a tuple, and we'll just use my fiance, for instance. She's 25 and she's in the Netherlands and she's a female, okay? And so we have different data here, okay? And so now what we can actually do is this is tuple assignment, which is age, location, and well, we need to create new variables because new age, new location, new sex equals person, okay? And then we can actually print new age, new location, and new sex, okay? And there we are, and there we have it, okay? Oh, well, that would probably help if I had done that, huh? Okay, there we are. So, and now you can see that we have our tuple which assigned the variables across, and so it has to have the correct amount of parameters. You could do this, let's see, right, you could do that, but it needs to have the exact amount. Okay, so you can't try to unpack with less than what you have. Okay, it just doesn't work. And also, if you try to do it the other way, new race. Okay, if you try to do that, again, it's not enough values. Expected 4, got 3. So you have to have the exact amount of variables as you have values in tuples. Okay, so that's about it when it comes to tuples, right? Like, why do we use tuples? We use them because they're faster. Ultimately, they're faster, they're smaller, they're more efficient than lists. And when it comes to a simplified data structure, ultimately, lists are a relatively simple data structure, just as tuples are relatively simple data structures. They're not like a dictionary which has a unique identifier. It doesn't have a key value pair. Okay, so and as you saw with this, actually it just pulls the keys, right? So we're not even getting the full data point there. That's, that's frustrating, right? So if we were to if we were wanting to do this, we would have to do x7 equals let's see, we'd have to do x7 equals x2 dot pop, and we'd have to get the, we could go for 2, right? But we'd have to do this multiple times, like print x7, and then sure, yeah, we could get our value there, but it would be more of a hassle. Okay, so that's really what it comes down to. I appreciate you coming by, watching the video. I hope you learned something. Make sure you like, you comment, you subscribe. I appreciate everybody who has something to say, and those who do enjoy the content. Have a good day, happy coding, and happy holidays.